Hello and welcome, my dear students, to my channel Mathematics Made Easy. This is Ms. Ruchika welcoming you to today's session. In today's session for Grade 10 Elite Math, we are continuing Module 7 Rational Functions, and this video is part 2 of Module 7 Lesson 1 Multiplying and Dividing Rational Expressions. So in the last video, you simplified rational expressions by factorization, and in today's session, our learning objective would be to simplify rational expressions by multiplying and dividing. Also, we are going to look at complex fractions. So if you have not watched part 1 of the series, I would urge you to watch. I will put the link in the description box. That will make understanding this video more easy for you. So let's dive into the video and see what we are learning today. Okay, so now that you've understood about simplifying a rational expression from the last video, let's move forward and understand multiplication of two rational functions. So when I'm doing multiplication of rational expressions, let's see through an example what are the steps involved. So I'm taking here two rational expressions. The first one that I'm taking is 3x over 8y. So this is one numerator over denominator form. And the second one that I'm taking is 12x square y over 9xy cube. So these are the two rational expressions that we are trying to multiply. So I'm putting that cross. Now look here carefully. This has a numerator, this has a denominator, this has a numerator, this has a denominator. Now let's observe a little bit more carefully. There is one part which is the number part in each of these, and one part which is the variable part like x, y, x square y, and so on. So when we are doing the multiplication, what we'll try, we'll use the like term concept and we'll take the number in the numerator with the number in the numerator. So 3 will combine with 12, 8 will combine with 9 in the same order, numerator with numerator, denominator with denominator. And then we'll take the variable with the variable. So x will go with x square y will go with xy cube. Okay, so number with number, variable with variable. Now you can simplify. 3 3s are 9 and you divide this with 4. So 4 3s are 12, 4 2s are 8. So this gives you 1 over 2 only in the number part, as 3 and 3 is going to cancel. Now let's look at the variable part. In variable x and x, y and y also cancel. So you are left with x square over y cube. This is the simplified form of multiplication. Okay, let's take one more example on multiplication just to make you more comfortable. So this was the first example. Let's take another one. So here I'm taking 6x square y over 5xy square, the first rational expression, and I'm multiplying it with the second one, 10xy over 9y square. Okay, we'll apply the same technique. We'll take the numbers together and we'll take the variables together. Numerator with numerator, denominator with denominator. Now I'm going to select x square y with xy square and xy square with 9y square. So x square y times xy over xy square times y square. Now let's see what all is going to cancel. Y square will cancel with this, x will cancel with this, 5 2s are 10, 3 2s are 6, 3 3s are 9. So you are left with 4 by 3 in the number part, x square in the numerator and y square in denominator. So it's a pretty easy concept. Whatever is the common terms in the numerator denominator, you cancel, take number with number, and so on. So that was about multiplication. Let's take some examples on division now. Now that you've learned multiplication, let's do some questions on division also and understand the concept well. So now we are learning how we divide rational expressions. So let me begin with an example here also. So I'm going to now take two rational expressions. The first one that I'm selecting is 10d to the power 5 divided by 6cd. So that's your first rational expression, and you are dividing it with the second one, which is 30c cube d square divided by 4c. Okay, now you see the variable has changed. The variable is C and D here, but there are numbers involved. So we are going to do the same concept, number with number and variable with variable. So the variables will be combined with variables, numbers with numbers. But here the difference is this is division. And I hope you remember that division is the reciprocal of if you want to convert your division to multiplication, it is like an inverse. So what I'm going to be doing here, watch carefully, there are two rational expressions, 1 and 2. The one which is getting divided, I'm going to take its reciprocal and change it to multiplication, because we are all more comfortable with multiplication. So the first one is as it is, and when I change the division to multiplication, I take the reciprocal of the second term, means the numerator becomes denominator, denominator becomes numerator. You flip it. So 4c comes on the top, 30c cube d square comes here. Now let's cancel the common factors and combine just like multiplication. So 10 will be combined with 4, 6 will be multiplied with 30, and d to the power 5c cd multiplied with c cube d square. So let's see what's cancelling. 0 cancels with 0. This is 2 times 3, so 2 over 9. That's the number part that you are getting. And let's look here. So here you have c cancelling with c, d to the power 5, and in the denominator you have d to the power 3. So d to the power 5 divided by d to the power 3, that's what you are going to combine, and 1c cube is as it is. So this is going to give you 2 by 9 d to the power 2 over c cube. Now if some of you are considering are thinking how this changed to this, then I will recall the law of exponent for you. If you have the same base, different power, and you are dividing, okay, then the power gets subtracted. So the power got subtracted and it became 5 minus 3, which is 2. So what did I use? I used law of exponent. So always remember, if it is division, the power gets subtracted. If it is addition, the power gets added. So that was a simple example. Now I want you to try one question yourself. Okay, so the two rational expressions I'm giving you is these. This is the first one, ab whole cube, and the one which you are dividing it is 18ab over 2b square. So please go ahead, start dividing. So step 1 would be to change division to multiplication and take the reciprocal of this. So 2b square comes up, 18ab goes down. 27 a squared b. Now here ab whole is multiplied with the power 3, so it can be written as a cube b cube, so that it is easy to simplify. Now let's collect the terms together. So 27, 2 and 18 numbers come together and variables go in the other side. Now before I take the variables together, I can also do some sort of cancellation here if you see. So I'm going to write in this way. So I'm combining the variable with the variable. Now what variables are going to cancel? It's careful. You have to be careful. So if you see, first of all, I can make this simple by changing this to 9. And what you get in the number is only 3. Everything else cancels. Now if you look in the numerator, the power is a square. Here 1 is multiplied, b1 multiplied to b2, base is same, power is different, power is added. So this is b cube. In the denominator, a3 with a1 would give you a4. B cubed with this will give you b4. So now it is easy for you to compare. So what is happening? A square is cancelling. A square will cancel with a square, you are left with a square. B cube will cancel with b, and you are just left with 1b. So numerator becomes 1, and then the final answer can be written as 3 over a square b. That's your answer. Now let me give you a challenge problem, a hot question. I want you to think about this one and try to solve yourself in your notebook and then check your answer. So if I give you something like this, x square plus 15x plus 50 over x plus 2 divided by x square minus 30x plus 200 over x plus 2. I want you to simplify this. So it's division. What should be the first step? Change it to multiplication. Take reciprocal. So x plus 2 is going to come on the top, and x square plus 30x plus 200 is going to go down. Easy. And now you would see that your question would simplify a little bit, as x plus 2 is common. So we can cancel it. It will go from here. So you are now left with x square plus 15x plus 50 divided by x square plus 30x plus 200. I hope this sounds familiar to you, and you know that middle term splitting is the thing that is going to help you for simplification. We have done questions like this in part 1 of the video. In case you want to revise and revisit the concept, please watch part 1 once more. Okay, so we need the middle term. We need to now factor the numerator and denominator. So what are going to be the factors? Let's do it a little bit here. So I need two numbers a and b such that the sum is 15 and the product is 50. So it's an easy one. Two numbers which when multiplied gives you 50 and which when added gives you 15 are 5 and 10. So I can directly write this as x plus 5, x plus 10. Now you are comfortable with middle term splitting. Now let's look at the denominator. You need two numbers which when added gives you 30 and which when multiplied gives you 200. That means you're looking at the factors of 200. So what can be those two numbers? Again, it's an easy one, x plus 10 and x plus 20, because 10 multiplied with 20 is 200 and 10 added to 20 is 30. Now pretty easy, one term is cancelling, so the final simplification would be x plus 5 in the numerator and x plus 20 in the denominator. So that's your final answer. It was a challenge question. I hope many of you got it right. If you did, do let me know in the comment section that you have understood this concept. Objective of today's session, which is about complex fractions and how to simplify them. So I'm going to begin by showing you an example of a complex fraction and giving you the definition, and then in the next slide we are going to simplify it. So what is a complex fraction? So as the name suggests, it's a fraction, means it is going to be dividing two things. It will have a numerator and a denominator, and the fraction is a little complex. And why it is complex? Because the numerator and denominator are also rational expressions. Now a rational expression, I hope you remember, is already having a numerator and denominator, and then there are two rational expressions. So there are two numerators. For example, this is one rational expression with a numerator and a denominator, and then another one like this, 6xy over 4x square minus say 4y square. Let me change it a little bit. Yeah. So these are two rational expressions, as you can See now, if these rational expressions, I'm going to divide them both. Like this one is one, this one is another one, and I divide them, I convert them into fraction. Then this is an example of a complex fraction. And as you see, it looks complicated. It's complex in nature because there are already two numerators, two denominators, and then we are dividing them, we are converting them into a fraction form. So this is same as you can write, just to make it more easy and to simplify, the first one divided by the second one. You can write it in this way also. And if you write in this way, then I hope looking at the division, you are able to identify what is going to be the next step. So if I want to simplify this complex fraction having a numerator and a denominator, which is another rational expression having another numerator and another denominator, then a simple way of doing it is to take the first one, divide by the second one, and then change the division to multiplication. So when you do that from your previous slide, I hope you can recall we flip the second term. So numerator and denominator are interchanged. This comes up, this goes down. Okay, now the next step would be to cancel any common factors and to simplify further. So if you see, 3x will cancel with 6x, it will come 2, and this term 4x square minus 4y square. I hope you can recall difference of square identity. These are perfect squares which are getting subtracted, so I can write them as 2x plus 4y, 2x minus 4y. So which identity I used? Difference of squares. So we have to just do the factorization in whichever best way we could. So I did that in the same order. And if you see here carefully, I can take a 2 common out. Okay, so let me just go to the next slide and finish this factorization. So from the last slide, we have seen that we can change the division to multiplication, and then 4x square minus 4y square can be simplified by taking 4 common, x square minus y square. So this is same as 4 times x plus y, x minus y. So this is difference of squares that I have done here to simplify. So this whole thing reduces to 3x over x minus y multiplied with, now this becomes reciprocal, we have changed it to multiplication. So 6xy comes down, 4x square minus 4y square goes up. Okay, now I'm going to come here and write, so 3x over x minus y multiplied with 4 times x plus y, x minus y. Now your life is easy because you can see something is cancelling. What is that something? This we had already cancelled in the last slide, and x minus y will go with x minus y. This 2 will go with this 2. So what is left eventually? Only 2 times x plus y over y. So this is your final answer which is left, and that's how you simplify a complex fraction. If you see, this was the question. This is what we started with. And what answer we reach to? This one. Definitely we have made it more simple, and we have just used the concept of changing the division to multiplication and taking reciprocal. So if you are now comfortable with factorization, you should be able to reach to the answer very, very confidently. That completes this question. That brings us to the end of today's session. Thank you for watching. If you liked the video, give it a thumbs up, and don't forget to subscribe to the channel, press the bell icon so that you don't miss any upcoming videos. Until then, this is Ms. Ruchika signing off from today's session. See you in my next video. Bye, students.